On June 10, 2018, a veteran explorer on Mars, a machine that had outlived its 90-day warranty by 15 years, sent its last, faint message back to Earth. Then, silence. The culprit wasn't some huge mechanical failure or the planet's bone-chilling cold. It was something way more sneaky. It was the dust. NASA's Opportunity rover, a tough little machine we all thought was invincible, was basically choked to death by the red soil of Mars. This wasn't just a sad end to a mission. It was a terrifying preview of the biggest threat facing the first people who will walk on that world. Because the same dust that killed our robot could just as easily kill us. And the reasons why are stranger and scarier than you can probably imagine. Here on Earth, we think of dust as a bit of a nuisance, something you wipe off a shelf. But on Mars, dust is a planet-sized menace. It's a killer hiding in plain sight. And why it's so lethal isn't just about a big sandstorm. It's a story of weird atmospheric physics, toxic chemicals, and a danger that we're really only just starting to wrap our heads around. The real reason Martian dust is so deadly has less to do with wind, and everything to do with the very nature of Mars itself. So to get why this dust is so dangerous, you have to understand what it is. Martian dust is completely different from the sand and dirt here on Earth. For starters, its particles are microscopic, with an average size of just 3 micrometers. That's tiny, about 4% of the width of a single human hair. Think about something as fine as smoke or talcum powder. Now picture an entire planet covered in that stuff, sometimes feet deep. That incredible fineness is problem number 1. On Earth, our thick atmosphere and stronger gravity tend to keep dust from getting too out of control. A Saharan sandstorm is a big deal, but it eventually settles down. Gravity pulls the particles down, and rain washes them out of the air. Mars doesn't really have those safety features. Its atmosphere is only about 1% as dense as ours, and its gravity is just a third of what we feel. This combo is the perfect recipe for dust to just stay up. Once it's kicked into the air, it doesn't want to come back down. There's no rain on Mars to clear things out, which means storms can stick around for weeks or even months. But the real secret to their scary size is a runaway feedback loop. It all starts with the sun. As sunlight heats the Martian ground, pockets of air rise, taking the superfine dust with them. And this is where the trap is set. Those suspended dust particles, full of iron oxide, absorb even more sunlight, heating the air around them. This warmer layer of air then rises faster, which creates stronger winds, which kicks up even more dust. More dust means more heat, which means stronger winds, which means more dust. It's an exponential cycle that feeds itself. A small local dust-up can grow and grow until it merges with other storms. Every few Martian years, these continent-sized storms combine into one monster global storm that wraps the entire planet in a suffocating red haze. This is what killed the Opportunity rover. The sky got so dark that its solar panels couldn't make power, its batteries died, and it froze in the endless twilight. Losing power is one thing for a robot. For humans, the danger is way more personal. The dust won't just block the sun, it will attack our bodies and our tech from the inside out. Let's start with what happens if you breathe it in. And you will breathe it in. It doesn't matter how well built our habitats are, this dust will find a way inside. After just a few days on the moon, the Apollo astronauts came back with lunar dust all over their suits that gave them sore throats, coughs, and watery eyes, what they called lunar hay fever. Martian dust would be so much worse. Because it's so tiny, Martian dust can get past our respiratory system's natural defenses, like the mucus in our lungs, which can't stop particles that small. They can get stuck deep in your lung tissue and maybe even get into your bloodstream. This is a lot like silicosis, a nasty incurable lung disease that miners on Earth can get from breathing in fine silica dust. And guess what? Martian dust is loaded with silica. Long-term exposure could scar your lungs and make it hard to breathe. Basically a death sentence when you're millions of miles from the nearest hospital. But it gets worse. The soil on Mars is full of toxic chemicals. The main culprits are perchlorates, a type of salt-like compound. They're pretty rare on Earth, but on Mars, they're all over the place in concentrations that are toxic to us. If you inhale or swallow them, perchlorates can mess with your thyroid gland, which controls hormones all over your body. This can cause all sorts of issues, like anemia and other serious diseases. Scientists figure that breathing in just a few milligrams of Martian dust would be more than a safe dose. The soil also has other toxic heavy metals like arsenic, chromium, and beryllium. While the amounts might be low, The risk from being exposed to them over a mission that lasts more than a year is a huge, terrifying question mark. And this dust isn't just chemically mean, it's physically aggressive. The particles are sharp and abrasive, like microscopic bits of glass. Plus, because of the dry, thin air, they get electrostatically charged, so they cling to everything like packing peanuts. This dust will get all over astronaut visors, making it hard to see. It'll grind its way into the joints and seals of spacesuits, wearing them down and causing leaks. A leaky suit on Mars is game over. It will sneak into habitats, getting into the air and water. It will clog up sensitive instruments and jam up moving parts like gears and airlocks. There's even a chance of static discharge. All those trillions of dust particles rubbing against each other in the air could build up a huge static charge, possibly creating sparks that could fry essential electronics or mess with communications. Basically, every single part of a human mission, from the crew's health to their life support, is under attack by this relentless red powder. So surviving on Mars isn't just about having a place to live. It's about fighting a non-stop war against the dust. And you better believe NASA and other space agencies are taking this threat seriously. The solutions they're working on are just as futuristic as the problem itself. The first line of defense is trying to predict the storms. If we can see them coming, we can batten down the hatches. Orbiters like the Mars Reconnaissance Orbiter are constantly watching the planet's weather, looking for the first signs of a storm, especially in places where they tend to start, like the Hellas Basin. If we can figure out what triggers them, like sudden spikes in surface temperature, we can hopefully one day forecast Martian weather just like we do here on Earth. But you can't just hide from a storm that covers the whole planet for a month. That means technology has to be our shield. For power, future missions won't be using solar panels. They'll likely rely on nuclear sources, like the radioisotope thermoelectric generators, or RTGs, that the Curiosity and Perseverance rovers use. These are basically nuclear batteries that don't care if the sun is out, making sure habitats and vehicles stay powered up through the darkest storms. To protect the astronauts, we need defenses on top of defenses. Super advanced filtration systems inside the habitats will be key to scrubbing any dust that gets in out of the air. But the real trick is keeping the dust out to begin with. This has led to some really cool active dust-fighting technologies. One of the most promising is the Electrodynamic Dust Shield, or EDS. This is an amazing piece of tech that puts a nearly invisible grid of wires onto a surface, like a solar panel or an astronaut's visor. By running a tiny bit of power through these wires, it creates an electric field that acts like a wave, literally lifting the charged dust particles up and pushing them right off the surface. It's a surface that cleans itself, no wiping needed. They're working on putting this tech on everything from spacesuit fabrics to camera lenses. Other ideas include new suit designs with magnetic seals, special airlocks that can clean a suit before an astronaut gets back inside, and creating new materials that naturally repel dust. There's no single easy answer. Survival is going to come down to a mix of smart forecasting, tough engineering, and brand new technologies designed to fight the dust on every front. When you think about it, the Martian dust problem is just incredible. It's an attack from every possible angle, chemically, physically, and environmentally. It makes you wonder, what do you think is the biggest danger the dust poses? Is it the long-term health risk from its toxins? The immediate threat of it breaking life support gear? Or maybe the psychological toll of living under a dark red sky for weeks at a time? Let me know what you think in the comments. And if you find these deep dives into the wild challenges of space exploration as fascinating as I do, make sure to subscribe and hit that notification bell so you don't miss what's next. The silent, frozen end of the Opportunity rover was more than just a sad finale to an incredible mission. It was Mars sending us a warning loud and clear. The dream of humanity becoming a multi-planetary species won't happen just by building a big enough rocket. The real challenge isn't the empty space between worlds, but the struggle to survive on a new one. The fine red dust of Mars is a unique product of that planet's history, a leftover from an ancient, watery past that has become a modern-day killer. It's a force of nature working on rules we're still trying to figure out. Before we can plant a flag, before we can build a city, we have to learn how to conquer the dust. Because on Mars, the ground you walk on is just as deadly as the vacuum of space over your head. And solving this one massive problem is the key that could finally unlock our future on the red planet.